We are, in fact, doing that. Other questions? How in the back there?
Yeah, actually, we've got Tyree Wild, the National Weather Service.
Okay.
Yeah, mine's a two-part question. I was wondering if you could speak to the computational time it takes for your 0.44 kilometer model to run maybe out 24 hours. And the second part of my question is there any plans to expand your domain for your 1.33 kilometer model into Oregon?
Okay. If you want a bigger domain, you buy me some computers. That's the answer to that one. Right now, we run our 1.33 kilometer domain out 48 hours. We do it on 136 processors, okay? Is what we do it on right now, with very fast interconnects between the nodes. It takes approximately 4 hours to run that 48-hour forecast at that resolution for the domain. We've expanded the domain as we got contributors, like for instance, recently the state of Idaho and the Indian tribes contributed some money for more processors. So we're limited by computer power. I mean, one thing I'm pushing for right now is to get a massive new computer for the National Weather Service. So the National Weather Service will have the capability to run high resolution over the whole United States, both deterministically and probabilistically. And Senator Maria Cantwell, who's the senator who got the Langley radar, she is very enthusiastic about getting a petaflop computer for the National Weather Service, which will give them the capabilities to do this kind of thing. So let's hope.
Upper corner up there, Tyler.
Tyler Mode, just a weather watcher. My question is, do you see a difference in ensemble spread with extreme air masses, hot or cold, like in how well they predict the weather?
I don't know exactly how to answer that. I mean, the ensemble is one tool of getting at forecasting extremes. And in fact, you want as large an ensemble as possible to get a chance of getting at the extremes. So it's not, that is one approach to get at the extremes. You have a better chance of capturing the potential for extreme if you have an ensemble of forecasts rather than a single forecast. You might see, if I was working in the Weather Service, or whatever, if I saw the if I saw that there's, a 1 in 10 chance of a major event, it's valuable to know that, and then be able to perhaps let people know that the potential for an extreme event exists. So I think ensembles are one way to get at that, and I think we could improve our ability to get at the extremes by using ensemble forecasts.
Okay, Cliff and I talked about this question ahead of time because it's been on the minds of a few people. Just real quickly, we don't have to go in depth in this, but give us your thoughts on our 2 global warming meetings that we hosted this year from maybe an AMS perspective for doing it, and then perhaps what you saw, because I know you asked me to view both videos after each was done. Give us your thoughts.
Okay. Okay, did you get kicked out of here?
No, you're okay. Just don't say the wrong thing.
I should warn you, I am known a little bit as the skeptic in my department.
Just kidding.
Yeah. Actually, I believe in global warming. I think it's undoubtedly real what's going to happen. Okay, I mean, we are mucking around with the radiation balance of the planet. There is no way that if we add a lot of greenhouse gases, we're not going to warm the planet. Okay? There's no doubt about it. I mean, it's absolutely rock solid. And people who are telling you that it ain't going to happen, or solar variability, or something else is going to stop it, are absolutely wrong. I mean, we are talking about a major perturbation. But the interesting thing about global warming is most of it's coming up. What we've seen so far is nothing compared to what's going to happen by the end of the century. So on one hand, I'm a great believer in global warming. It's going to happen, okay? But the thing is, you've got to be careful about this. First, there's been a number of people that have overhyped it. There's some people who, some of my colleagues who think that global warming is serious. There's a lot of bad implications. And so it's okay to just kind of exaggerate it a bit. And the worst exaggeration is pointing to what's happening now or happened recently, and claim that's caused by global warming, anthropogenic global warming. This is really bad stuff, okay? And this has been going on for a little while. One I have fought against is this business about the snowpack, okay? There's a certain local Oregon meteorologist who used to be at the University of Washington, I won't name, but who spoke here, who, you know, was really pushing very hard the idea that the snowpack, you know, there's a 50% loss of snowpack. We also already have massive loss of snowpack, and due to global warming and anthropogenic origins. And I think that is not true. In fact, I wrote a paper with some other people proving it wasn't true, and it was published in the Journal of Climate. This is the peer-reviewed literature basically showing why it wasn't a 50% reduction of snowpack. So there's a lot of people, and it's not only this guy, but there's a number of people who think they have to point to individual events like Katrina, or like the heat wave in the Midwest, or the heat wave in Russia, and say that's due to global warming. There's even this group that they have some big gathering about collecting, this 350.org and connecting the dots. I mean, this stuff is really bad. Basically, they want to save the world, and so they're pointing to individual extreme events and claiming that's some proof that's caused by mankind's intervention. And there's just no basis for most of this stuff, okay? So, we gotta be careful. This is a serious threat, and it's one that we can't overhype what has happened. Now, my personal opinion is that we're not gonna stop it. Mankind is going to do this experiment. There is no hint to me that we are really going to do much about greenhouse gases. Look at the plots, they're going up like this, right? There are people, to change the trajectory of the warming, we would have to massively reduce our fossil fuel use. And we ain't doing it, folks. In fact, it's getting worse. I mean, coal, we're about to ship coal to China. China's putting in these new coal plants right and left, okay? We're not gonna stop it. To me, the only way, so we're gonna have to learn to adapt to global warming. And for me, weather forecasting is one of the prime ways to adapt. Because we know if there is a change in severe weather due to global warming, at least we'll be able to forecast it. To me, the way to get out of it is, I mean, there's two things we've got to do. One, our government needs to work on technological changes. We have to make not using fossil fuels economic, really economic, and make it economic for other countries. We need to be able to do that. And that's the only way we're going to get away from this trajectory, I think. So anyway, that's my take on the global warming.
Jim, let's take one from your side. Any questions?
How quiet people
Either
are.
side.
In the back.
Hey, Jim, why don't, okay, go ahead.
Hello, Tara Bishop. I'm the local combat meteorologist. With your 1.3 kilometer grid models, when the National Weather Service actually gets the computers to do it, will these be movable location windows the way the military has them?
Well, right now, the Weather Service now, they recently made some changes, and they now have the ability to do a 1.3 kilometer, we call it a nest. They can move it around. I don't know if they've ever moved it here. Have they ever moved it here, Steve? No. He hasn't seen it. I haven't seen it around here, but supposedly, I can't find it on the web, but supposedly they have the capability to do that. I mean, down the road, I mean, with the right computers, they should be able to do this over the whole country, right?
The road, sure.
And in fact, you might connect it with the ensemble. You might find the most probable ensemble member and use that to drive the high-resolution forecast. I mean, there's combinations like that. So right now, they do have that nested capability.
Right. Oh, I had a follow-up.
Sure, go ahead.
This is actually for Steve. Did you get enough money, or do we need to pitch some money in the hat?
We're good. I hear we just broke even.
Okay.
On the weather station. Thank you.
Okay.
Well, keep listening. You should do more here.
Yeah, we got one right here in the blue.
Okay,
I'm just an engineer, so the math
that's
information.
okay.
But I know you've talked in your blog, you've mentioned the error correction for the initial observations, and that you've been working on something for years apparently to change that with the National Weather Service, or I don't know if it's yours personally. Why has it taken years? If the math looks good, why can't it be implemented?
What are you talking about? The high-resolution stuff, or
No, I
the
think-
probabilistic forecasting?
No,
or-
it's, see if I can remember it correctly, my apologies. I think right now we're using the third order error correction on the initial observations.
Oh, the data simulation. Oh, data, okay, yeah.
And I
Okay.
think you talked about Bayesian, I believe.
Okay, yeah, okay, a little separate. We got things mixed.
Sorry.
Why is the National Weather Service not the #1 weather prediction entity in the world? It should be. Numerical weather prediction was invented in this country. The dominant country in terms of the research in weather prediction is here. Why do we not have the #1 global weather prediction in the world? And we don't. We're like 3rd or 4th now. Okay, it's embarrassing, and it has to change. The reason is, first, they don't have as much computer power for global weather prediction. That's a real issue, okay? The European Center has much more computer power, and this is ridiculous. The other thing is they don't use, the Weather Service doesn't use as advanced approach to data simulation. They use something called 3D VAR, while these are the guys use 4D VAR. And basically, the simple way to understand this is 3D VAR, you try to do the best you can at individual time, describing the atmosphere. 4D VAR, you try to not only describe it well what's happening at a certain time, but also the times leading up to it. This is a lack of computer power that's driven that too. So basically, the Weather Service could catch up. It takes more computer power, is would be the first thing